Okay, this is the video for the second half of worksheet 1C. We're going to pick up with number 10, and we're given the function f of x equals negative absolute value of x plus 1 plus 6. So we're supposed to identify the parent. The parent would be f of x equals absolute value of x. Okay, so once we've identified the parent function, we need to sketch the graph of this thing and then analyze the function identifying key features listed below. So let's start with the stuff in English. The negative in front means that we are going to flip on the x-axis up and down, and then we are going to go left 1, and we're going to go up 6. So I guess first of all we need to figure out where it starts at the origin, and we're going left 1 and up 6. 1, 2, 3, 4, 5, 6. And this thing is flipping down, not up. And your typical parent function for absolute value is going to go diagonally through the corners of the boxes. So we're going to do that, and we're going to do that. Not quite so easy drawing with this tablet and stylus, but anyway, so that's what it should look like. Should look like a slope of 1 and slope of negative 1 on either side of this. So we have flipped it on the x-axis. It's now pointing down instead of up, and we move the vertex left 1 up 6. So we should be good to go. We sketched the graph, we identified the parent, and we identified the key features. Okay. Oh, these are the key features. All right. So if we have this over 1 up 1, 2, 3, 4, 5, 6, and we are going down like this, and we are going down like that. Our domain, we're going to go forever in both directions, left and right. Our range, we're only going as far up as 1, 2, 3, 4, 5, 6. So our range goes from 6 down to negative infinity. That means we need to do the negative infinity first. Then the 6, is 6 included as part of the solution? Yes. So we get a bracket there. The x-intercepts are going to be at negative 1, 2, 3, 4, 5, 6, 7, negative 7. And if that's positive 7, that's going to be 5. So our x-intercepts are at negative 7, 0, and 5, 0. And our y-intercept is happening here, where it's 5, 0, 5. The parent function, okay, that's where we're doing that there with absolute value of x. Increasing, it is, and again, we need to stop and ask the question. We're watching what y is doing, but what is x doing from there until negative 1 is where it changes directions, and then it goes on to positive infinity. So increasing, it's going to be from negative infinity to negative 1, and negative 1 is not a part of the answer. Up there at the top, it's neither going up nor down. Meanwhile, for the decreasing, it picks up at negative 1 and goes to positive infinity. The negative, the only parts of this that are negative are from negative infinity to negative 7. And then over completely on the other side, everything above 5. So that's what our negative is going to look like. Now, to sketch this again. 1, 2, 3, 4, 5, 6. that. That's -7, that's 5, that's 6. Now, we don't have any minimums because the only minimums we got are going forever down in that direction. So we have no local minimums. And technically, you know, I guess you've seen me do either that or that. I would accept both. Relative max and absolute max is going to be the same point. You're at -1 and 6. And there is only one mountaintop that we're playing with here, and it doesn't get any higher than that. Now, the positive value picking up from up above, it goes from -infinity to -7 to 5 to positive infinity. And the positive values are going to be from -7 to +5. That's where everything is above the line there. And of course, we can't include those. There's no brackets here because where it crosses the x-axis, those are 0 values and they're not positive. All right, endpoint behavior. Let's say as x approaches -infinity, y is also going down, -infinity. And as x approaches positive infinity, y is still going down. So that's going to handle number 10. Number 11 is going to do the same kind of things. I'll tell you what, we're just going to scroll down here and we're going to, well, that's right, we still have to identify the key features. So this, well, I'm still going to do this. Your parent is y equal, well, that's right, we're doing this in terms of f of x. F of x equals 2 to the x. So all this does is just moves it up 3. All right, now we're going to draw it on the next one. So normally, I'm first of all going to sketch what normally a normal something to the x, whether it's 2 to the x or 3 to the x, they're all going to pass through 0, 1. And they're all going to come down here and do this kind of thing. And then you think about it, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. And so that's what that graph is going to be doing. Now, what we're doing is we're shifting every bit of that up 3 units. So this goes up 1, 2, 3. This goes up 1, 2, 3. This goes up 1, 2, 3. And meanwhile, this guy down here, I'm going to switch to this color because this axis behaves like an asymptote. Now, I'm hoping you heard that word last year. Asymptote is that imaginary line where it gets closer and closer and closer, but it never quite touches it. So our asymptote also moves up 3. 1, 2, 3. Our asymptote is now here. And so we're going to take our red line and we're going to start like right there. And then we're going to start to swing up like that. And well, I'm going to say, I'm first of all going to get rid of that. And we're going to say that the parent function was 2 of x, or 2 to the x, but this is 2 to the x plus 3, just so that we are clear on the difference between the two. So we've done our graphing. Now we need to figure out domain and range and so on. Now this graph goes on forever to the left and will keep going forever to the right. So it will do that. The range never quite touches 0. but it does go up. And so we're going to do that with the range. There are no x-intercepts, and there's only one y-intercept that is up here at 4, from 0, 1, 2, 3, 4. Yeah, that is 0, 4. Increasing, the whole thing is increasing. So we're going to do that. We're increasing, and there is no decreasing. Nothing is below the line, so nothing is negative. I think when I do this one here, I'm going to do that. All right, there's the graph. Now, as to a relative min, there's not really a relative min or an absolute min because it keeps getting closer and closer to 0. This one's going to be a tough one to explain. You know how as it approaches infinity, we can't really point out a spot and an ordered pair and say that's where that's going to be the absolute, right there at that spot. All right, sorry, I just got interrupted, so I'm going to have to get my head back into what I was trying to explain. As you are approaching infinity, you are getting, the further you go, there's no place that you can pinpoint that is the absolute, because it keeps going forever. Now, we're running into a same situation here with an exponential curve like this because it keeps getting closer and closer to 0. Just about the time that I think we're as close as we could humanly possible get to 0, there's another point in between those 2 points. And you can just keep squeezing them in between like that for eternity. And so, we will come close to 0, but never quite reach 0. Well, in this case, you're going to come close to where y is 3, but never quite reach it. So, our response here is that there is no local min, and there is no absolute min. Because just when I think I've gone as low as I can, it finds another point in between that it can go lower than that. So there is no minimum there, because it keeps going down in minute fractions. Now, as to the max, we run into the other end of the spectrum that there is no local max. It just keeps going up, which means that there is no absolute maximum. You could possibly argue infinity there. Positive, everybody is positive. Now remember, you're having to do this in terms of x. From negative infinity to positive infinity, everything is going to be above the x-axis. Endpoint behavior, this one takes an interesting turn. As x approaches negative infinity, y is approaching 0. No, excuse me. I keep forgetting we're not 0. Y is approaching 3. I keep thinking of the original curve, and we're not doing the original curve. We're doing this one that's been transformed. As x approaches positive infinity, now y is going through the ceiling. Okay. Now, the last one should be kind of fairly straight up. We're going left 1 and down 4. And this is a parabola now. Hopefully you remember that little game that I showed you. If I'm starting from the origin and I go left 1 and down 4, 1, 2, 3, 4, this is my new vertex. And this is where I'm going to, since I'm not flipping, I'm not stretching, I'm not monkeying with the shape of the thing, this is just like a standard parabola. Over 1, up 1, bang. Go back to the beginning. Over 2, up 4, 1, 2, 3, 4, bang. Go back to the beginning. Over 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm just going to come over here to the left side and do a mirror of what I'm seeing on the right side. And then I can draw that. Yeah, I probably made it look more like a V than I should. In any case, left 1 down 4. So here, left 1 down 1, 2, 3, 4. Bang, bang, bang. Mirror, mirror, mirror. All right, now let's answer some questions. Domain is going on forever in both directions. Range gets as low as -4, I believe. 1, 2, 3, 4. And goes up forever. -4 is a part of the range, so it's going to do that. X-intercepts, those are going to be approximate. You know, you're going to say maybe -3.2 and 0, and you're also going to say 1.5 and 0. I put a question mark because I'm kind of guessing. The y-intercept is going to be a little easier to nail. 0, -3. Parent function, this is a parabola. Increasing. Now we have to stop and ask ourselves, what is x doing right here? It bottoms out where x is -1, and then it goes forever in the other direction. So it's increasing from -1 to infinity, but it's decreasing from -infinity as far as -1. The negative value, we're going to come back to these x-intercepts, and it's going to be about -3.2 as far as 1.5. And of course, we can't include the x-intercepts themselves because they're 0 value, not negative, not positive. All right. Now, recreate the graph. 1, 2, 3, 4, 1. Okay, flip side. And we can draw a nice little parabola there. All right. Relative min and absolute min are the same thing. They are the ordered pair of -1 and -4. There is no relative max and there is no absolute max. You could possibly say infinity there. Positive, this is going from that -4.2 to the +1.5. Oh, wait a minute, I'm sorry. I got to think of this backwards. This is going from -infinity to as far as the -4.2, and then it picks up with the 1.5, and it goes to +infinity. And then the endpoint behaviors, as x approaches -infinity, y is going up, and as x is approaching +infinity, y is still going up. Okay, and that is it for worksheet 1-C.